Hello, you're welcome to this lesson. In this video, I'm going to learn how to find a unit tangent vector, unit normal vector, and then the binormal vector of a curve in space. So let's consider this curve here, okay, to be defined by this vector function of t here, which is equal to x of t, y of t, and then z of t. Okay, so let's say this curve here is defined by this vector function here. Okay, so now let's go ahead and then talk about this figure that I have here. So for this figure here, this red arrow here represents the unit tangent vector, which is tangent to the curve. And then this yellow one here represents the unit normal vector, which is perpendicular or orthogonal to the unit tangent vector. Okay, and then the green one here is the binormal vector, okay, which is orthogonal to both the unit tangent vector and then the unit normal vector. So that's what the figure represents. Now let's look at what you are going to do. We are going to find a way to calculate for the unit tangent vector, unit normal vector, and then the binormal vector. So let's look at what you are going to do. So for this vector function here, okay, for this vector function here, if I find the derivative of this vector function, which will be r prime of t, okay, which will be equal to x prime of t, y prime of t, and then z prime of t. Okay, we can call this new vector function here as the tangent vector. Okay, we can call this the tangent vector. Okay, so now what will happen here is that if I find the unit vector of this tangent vector, that gives us the unit tangent vector. Okay, so let's call that means. So with this vector function that we have here, okay, I'm going to find the unit vector for this vector function. And then you know that before you can find the unit vector, you must know the magnitude of the vector function. So the magnitude of this vector function here, okay, which we write with this expression here, or termed as the norm. Okay, this expression here, which is termed as the norm of the first derivative of this vector function here. Okay, you must first find this norm before you can find the unit vector of the tangent vector. So one thing you have to know is that the unit vector of the tangent vector will be this unit tangent vector. So you can see that the unit tangent vector will be equal to the first derivative of the vector function, okay, over the norm of the vector function. Okay, so this is what you have. So this will be the expression that you are going to use if you want to find the unit tangent vector. Okay, so let's write this down here. Okay, so this is for the unit tangent vector. So what if you want to find the unit normal vector? To find the unit normal vector, you must find the unit vector of the unit tangent vector. Okay, so let's call what that means. So we have the unit tangent vector to be this vector function here. Okay, so the unit normal vector, okay, the unit normal vector will be equal to the unit tangent vector. Okay, that's the derivative of the unit tangent vector divided by its norm. Okay, divided by its norm. So this expression here will give us the unit normal vector. Let's take note of this also. So now, to find the binomial vector, all you need to do is to take the cross product of the unit tangent vector and then the unit normal vector. So the binomial vector will be equal to the cross product of the unit tangent vector, right? So and that of the unit normal vector. So if you ask to find the unit tangent vector, unit normal vector, and then the binomial vector of this curve here, okay, these are the expressions that you are going to to use. So first of all, you'll be given the vector function here, and then you differentiate the vector function. Then you find the norm of the vector function. So from there, you are going to find the unit tangent vector using this expression here. Then after finding the unit tangent vector, you find the unit normal vector. Then to do this, you must differentiate the unit tangent vector and then divide it by its magnitude. And then from there, you take the cross product of the unit tangent vector and then the unit normal vector to get the binormal vector. For a better understanding, let's try our hands on an example. So I have this example here which says that given this vector function here, which is equal to cosine of t, sine of t, and then t, we should find the unit tangent vector, the unit normal vector, and then the binormal vector. So let's look at how you are going to do this. So you know that for the unit tangent vector, okay, the expression will be the unit tangent vector will be equal to the first derivative of the vector function, okay, divided by the norm of the first derivative of the vector function. Okay, this will be the expression for the unit tangent vector. So before you can find the unit tangent vector, you must first differentiate the vector function that we were given. Okay, so let's look at this. This is the vector function here, which is equal to cosine of t, sine of t, and then t. Okay, so now let's differentiate this vector function here. That gives us r prime of t. Okay, so when I differentiate cosine of t, that gives me minus sine of t. And then when I differentiate sine of t, that gives us cosine of t. And then when I differentiate t, that gives us 1. So now I have the first derivative of the vector function. Okay, so now let's find the magnitude. So the magnitude of this vector function here. Okay, so that will be equal to the square root of the square of the component functions, right? So that will be minus sine t squared. Okay, minus sine t squared plus cos t squared, okay, plus 1 squared, which is the same as what? 1. Okay, so let's rewrite this here. I'm going to have this to be sine squared t plus cos squared t, okay, plus 1. And then from trigonometric identities, we know that sine squared t cos squared t will be equal to 1. So at the end, we are going to have 1 plus 1. Okay, and then this will be equal to the square root of what? 2. So that will be the norm. So let's go ahead and find the unit tangent vector. So the unit tangent vector will be equal to the first derivative of the vector function. Okay, so that will be minus sine of t, okay, comma cosine of t, and then 1. Okay, and then you're going to divide all this by the norm. Okay, divide by the norm. So I will actually write this. Okay, I will actually write this and then, okay, so let's rewrite this as, you see, we are going to divide each of these components by the magnitude. Okay, so that will be minus sine of t divided by the square root of 2. Okay, divided by the square root of 2, and then you have cosine of t divided by the square root of 2, then you have 1 over the square root of what? 2. Okay, so this will be the unit tangent vector. So now we will have to find the unit normal vector. Okay, so let's look at the expression for the unit normal vector. The unit normal vector, okay, is given as the derivative of the unit tangent vector, okay, divided by its magnitude. That's the magnitude of the derivative. Okay, so let's look at that. So now we need the derivative of this function here. Okay, so let's look at that. Let me write the function that we can continue from there. We have minus sine t over square root of 2, comma cosine of t divided by the square root of 2 and then 1 over square root of 2. So let's find the derivative of this function here. Okay, so the derivative of this function here, I'm going to have something like minus 1 over root 2, okay, times what? Sine of t. And then you know the derivative of sine of t will be cosine of t. So you're going to have this here. Then similarly, you will have 1 over root 2 multiplying the derivative of cosine of t, that would be sine of t. Okay, and then you know the derivative of this constant here will be 0. So we have 0 here. Okay, so now let's simplify this here. Okay, so okay, I think I made a mistake here. The derivative of cosine of t will be minus sine of t. Okay, let's correct that. So now let's simplify this. We are going to have this to be equal to minus cosine of t over root 2, then minus sine of t over root 2. Okay, so we have this here. Okay, so now let's find the magnitude of this derivative that we just got. So let's look at that. So I'm going to square each of the component, okay, and then take their square root. So that will be minus cosine of t by the square root of 2 squared. Okay, okay, so when I simplify this, I'm going to have cos, I have cos squared t divided by square root of 2 squared will give us 2, okay, then plus sine squared t divided by 2. Okay, so you can write this as the square root of cos squared t plus sine squared t, right? All divided by 2. And you know cos squared t plus sine squared t will give us 1. So we are going to have the square root of what? 1 over 2. Okay, so let's look at that. The square root of 1 over 2 will be equal to 1 over root 2. Okay, 1 over root 2. And I can write this as root 2 over root 2. You can choose to work with 1 over root 2. It's also the same. So now we know let's circle this. We know the derivative. Okay, we know the derivative. And then we know the norm to be root 2 on 2. Okay, we know the norm to be root 2 on 2. Let me write this again. That will be root 2 on 2. So let's consider the derivative and then the norm, okay, which is the root 2 on 2. So we are going to use these two expressions here to find the unit normal vector. So let's go ahead and then look at that. So for the unit normal vector, okay, that will be equal to the derivative, and then we know the derivative to be minus cosine of t root 2, and then minus sine of t root 2. So we are going to divide each of these term by the magnitude, which is the root 2 on 2 that we got, or the 1 over root 2. Okay, you can use the 1 over root 2 also. So let's look at that. So you are going to have this to be equal to minus cosine of t root 2. Okay, minus cosine of t root 2 divided by root 2 on 2. Okay, if you are using 1 over root 2 also, then you are going to make here 1 over root 2. Then we have comma minus sine of t divided by root 2 times root 2 on 2. Okay, so this is what you have now. You see that from here you can reciprocate what you have, right? So let's write this again. Then you're going to have this to be minus cosine of t divided by square root of 2 times 2 on root 2, right? And then have minus sine of t divided by root 2 times 2. It's actually division here. Okay, I made it multiplication divided by 2 on root 2. Okay, so let's look at this. When we simplify this, we're going to have minus 2 cosine of t divided by 2. Okay, because root of 2 times root of 2 gives us 2. Then we're going to have minus 2 sine of t divided by 2. Okay, so from here, these two can cancel out these two, and then this can also cancel out this. Okay, so let's look at what you're going to have then. So you're going to have this to be equal to minus cosine of t, and then minus sine of what? T. Okay, so this will be the unit normal vector. So now that you know the unit normal vector and then the unit tangent vector, you can go ahead and then find the binomial vector. Okay, so now these are the values that we got for the unit tangent vector and then the unit normal vector. Okay, so this is the unit tangent vector and then this is the unit normal vector. So the binomial vector, okay, the binomial vector will be equal to the cross product of these two vectors. Okay, so let's look at how you're going to do this. So you're going to use the determinant approach. Okay, so let's look at that. Let me start from here so that you can get more space. Okay, so I'm going to write the unit vectors I, j, and then k. Okay, so I have these unit vectors here. Then for the unit tangent vector, I have minus sine t divided by square root of 2. And then I have cosine of t divided by square root of 2. And then have 1 over root 2. And then for the unit normal vector, I have minus cosine of t and then minus sine of t, and then you have a third component, so let's make it 0. So let's look at what you are going to do. So first we are going to compute the determinant of what we have here. Okay, so let's look at that. So for the first term, we are going to cover the first column. Okay, so from there we are going to have cos t root 2 multiplying 0. Okay, cos t divided by 2 multiplying 0, which is these two things that I'm considering. Then that's going to give us 0, right? And then so that'll be 0 minus then minus sine t multiplying 1 over root 2. So that'll be minus sine t on root 2, right? So this is what you are going to have. So let's bring the I. And then minus, then let's do for the j also. So for the j, you are going to cover this then and then consider the remaining. So you have covered all this row and then you are considering the remaining. So you're going to have minus sine t on root 2 multiplying 0, then that gives us 0. Okay, and then that gives us 0. Okay, and then we will have minus cos t multiplying 1 over root 2. Okay, so that will be minus cos t over root 2. Okay, then we have j here and then plus. Let's look at the last one. So for this one, you're going to have minus sine t multiplying minus sine t, right? So that gives us sine squared t over root 2. So you're going to have sine squared t over square root of 2, okay? And then minus, then we will have minus cos squared t multiplying cos squared t on root 2. So that gives us plus cos squared t on root 2. Okay, so this is what you have now. Then you have 2. So now let's do some simplification here. Okay, so for this part, let me try and then move this up. So I moved it up so that you can get some space. So in simplifying this, okay, in simplifying this, we are going to have sine t on root 2, right? This minus minus becomes positive, okay, then I, okay, and then for here also, this minus minus becomes positive, okay, but because of this other minus, there will still be minus sign here, so we're going to have minus, you have minus cos t on root 2, okay, root 2j, okay, and then over here, so you're going to have plus, then you have sine squared t, cos squared t, and then they are all being divided by root 2, so you can have sine squared t plus cos squared t, okay, sine squared t plus cos squared t all divided by root 2, okay, and then you have the k here. Okay, so this will be the binomial vector. Okay, this will be the binomial vector, but I can write it in another form. Let's look at that. So I can write the binomial vector as, so I can write it by components. So you have sine t on root 2, right? And then you have minus cos t on root 2. Okay, and then we're going to have, since sine squared and then cos squared is equal to 1, you can rewrite this last term as 1 over root 2. Okay, 1 over root 2. So you are going to have 1 over root 2 here. So this will be the binomial unit vector. Okay, it is also a unit vector because it was a cross product of what, two unit vectors. So therefore, it will also be a unit vector. So this is how to find the unit tangent vector, the unit normal vector, and then the unit binomial vector. Thank you very much for watching this video. Please make sure you like and subscribe.